Right. So last time we were discussing about the vector analysis, and essentially we saw how to write, how to represent a vector in component form, as well as how to, rather than express in component form, how we saw how to resolve a vector into components once we know the magnitude of the vector and the angle that the vector is making. So we saw that vectors drawn as arrows can be resolved into components. So we saw that, if, for example, we have a vector like this, and it is making some angle with the x-axis which is known to us. We've drawn our x-axis like this, we've drawn our y-axis like this. So we know that with respect to our xy coordinate frame, this particular vector is at some angle theta. So we drop a perpendicular here, and we drop a perpendicular here. And it's just a matter of trigonometry now that we can say that this is what we call the x component of the vector, and this is what we call the y component of the vector. So we saw that this vector, if the magnitude of this vector is given by the symbol capital D, and this vector makes an angle of theta with respect to the x-axis, then its components are ax equal to a cos theta and ey equal to a sin theta. Okay, so these were the two equations which give us the components of the vector. So this is something that we looked at last time. So we'll continue with more analysis about this kind of thing today. Next, to answer your question, I don't have the maths recording link myself, but if you request your maths teacher, I think Saurabh sir is teaching you maths, he will be able to send you the link. And Purva, to answer your question, that yes, you should be making your own notes and writing down these explanations, as well as working out the questions, especially that I sent you. Okay. Okay, Dhyaneshwar, I will send the modules today. I have added myself to your group, so I will send you the physics module. I was actually not part of your group till earlier today, so I did not send. Okay. I had asked somebody to send to you, but it's okay. I will send to you. Right. So this is the concept that we learned last time. So let's quickly look at a couple of examples of this before we proceed further. Okay. So for example, I want to express the components for the vector E along the x-axis and the y-axis. So let's say we have a situation like this given to us, and with respect to some kind of coordinate frame which I've drawn, now vector E is shown like this. It has a magnitude of 20 units. and this angle is given to us as 30 degrees. So we have to find EX and EY. Just quickly work this out so that we can move on to the next thing. No, Visha, you have to check your values. Correct. Veer, your answer is correct. Dhruv, your answer is correct for EY. Dhyaneshwar, your answers are correct, but you have to give the values. You've just given the values of sine theta and cos theta. Okay. Dhyaneshwar, you have to give the values of the x component and y component. You have only given the values of the sine theta and cos theta. Adinath, correct. Okay, so far Adinath and Veer have got this correct. Yeah. Dhaneshwar, now your x component is correct. Okay. So let's quickly review this question. So you can see here that because this vector E is at an angle of 60 degrees with respect to the, sorry, rather 30 degrees with respect to y-axis. E angle 30 degrees here. That means what is the angle with respect to the x-axis? It is 60 degrees. Okay. So the angle that this vector E is making with the x-axis is 60 degrees, and the magnitude of E is 20 units. Okay, so this is the vector E. So x component of E is given by the formula E cos theta. So that will become 20 into cos 60 degrees, and cos 60 you know is half. So it will be 10. So x component is 10. This is the answer. And similarly, y component will become 10 root 3. Okay, so this will be 20 sine 60 degrees, and sine 60 you know is square root of 3 by 2. So your y component will become 10 root 3. Okay. So these are your final answers. 10 is the x component and 10 root 3 is the y component. These are the answers. Because theta is defined as the angle with respect to the x-axis. Theta का definition ही क्या होता है? Angle with respect to x-axis. And sine 60's value I have given to you last time is root 3 by 2. And cos 60's value I have given to you last time. This value is half. Just like you know that sine 30 is half. Cos 30 is root 3 by 2. I told you to memorize these values. Okay, you have to remember these. Sine 45 degrees is 1 by root 2. Cos 45 degrees is also 1 by root 2. So these are all values that you have to memorize. No, we have to take 60 only beta, because I have given the angle with respect to the y-axis as 30. So you can see how much is this angle. This angle is theta. So how much is theta? So you can see theta will be 60 degrees. Understood, Rishabh? Formula दिया है बेटा. Last time I have explained this formula. Yes, Arav. Okay. So you have to remember these formulas. That x component is the magnitude multiplied by cos theta. Y component is the magnitude multiplied by sin theta, where the definition of theta is that it is the angle with respect to x-axis. Okay, not the angle with respect to the y-axis. It is the angle with respect to the x-axis. This is a very specific formula. So you have to remember this. Okay, good. Now, next thing we'll see is, no, it is not given 30, Vanishka. That is the thing. The angle, see the diagram. Is the angle with the x-axis given as 30 degrees, beta? No, na. Vanishka, the angle is, this angle is 30. Okay. Is the angle with respect to the x-axis kitna ho ja raha hai? That is becoming 90 minus 30. So it is becoming 60 degrees. Okay. Is it clear now, Vanishka? Yes. Dhaneshwar, I have just sent the module. Okay, Vanishka. So good. That's clear now. All right. Okay. Now, next thing, next definition we will see is what is called standard unit vectors. In the XY system. So it's called standard because they are along a standard direction. Unit because the magnitude is 1. Okay. So the meaning of the term unit over here, this is used because these have magnitude equal to 1 and standard because their directions are standardized. So what are these standard unit vectors? They are given by the symbols I cap and j cap. So the symbol on top of the letter is called cap. Okay. So this is a unit vector, or you can say the standard unit vector along the x-axis. Okay. And this is the unit vector along the y-axis. So by unit vector we mean vector of magnitude 1. Okay. So again, to explain this in terms of the diagram, if this is your xy plane, This is your y-axis, this is your x-axis. Then I cap will be a vector of magnitude 1 along the x-axis. It will be like this. It will be a vector जिसका magnitude 1 है, जिसका direction किसके along है, x-axis के along. Similarly, j cap will be a vector whose direction is along the y-axis, but again whose magnitude is equal to unity. So j cap will again have a magnitude of unity, but its direction is along the y-axis. So these are called the standard unit vectors or the standardized unit vectors. This and this, they are called the standardized unit vectors because they have this property that their magnitude is unity or 1 and their directions are standardized. Okay, so just make a note of this definition. So these collectively, these two, they are called the standard unit vectors. But time से कोई मतलब ही नहीं है. These are constant unit vectors. Janeshwar, why you are relating this with time? I'm not talking about anything to do with time right now. We're just talking about standard unit vectors. Just like in physics, the unit of something is a standard quantity. Like 1 kg is a standard, 1 second is a standard. Like that. These are unit vectors. So they have a standard meaning. Okay, I cap is the symbol used for the standard unit vector along the x-axis, and j cap is the symbol used for the standard unit vector along the y-axis. Okay. So now the next thing we'll see is standard means it is standardized with respect to the x-axis and the y-axis. Yes, it is actually compulsory that I cap is along the x-axis and j cap is along the y-axis. ये जो मैंने definition लिखा है, this is a compulsory definition. We can't use the symbol I cap for any other direction. We can't use the symbol j cap for any other direction. The symbol I with a cap on top, इसका meaning है ये. It's a unit vector which is specifically along the x-axis. J cap is a unit vector which is specifically along the y-axis. Okay. Now the next thing we'll see here is now using the standard unit vectors. I cap and j cap. Any vector can be expressed in component form as Ex I cap plus E by j cap. So this is how we express a vector in what is called component form, where Ex is the x component of vector E. Ey is the y component of vector. So just make a note of this. So why we define I cap and j cap? So that we can express any vector like this in component form. nothing written after j cap. Any vector A can be expressed in component form. Any vector. Yes. Dhaneshwar, that is correct. Arshul, this is not exactly a formula. The formula is the one where you can get Ax in terms of theta and A and Ay in terms of theta and B. Okay, this is the expression itself. This is not a formula. This is the expression. We express the vector in this form. Okay. So further, in this we have to convert a vector given in geometrical form to component form. We use the formula. Now the formula comes. The x component is E cos theta and the y component is E sin theta. So this is the formula, okay, where E is magnitude of the vector and theta is the angle with respect to x-axis. Okay. So I'll give you time to write down just a minute. Okay. So for example, in the previous question, when we had that vector, जो कि ऐसा था, like this. So it had a magnitude of 20. It was making an angle with the x-axis of 60 degrees. So now in this, we have already used the formula we saw that Ax, which was A cos theta, became 10, and Ey, which was E sin theta, became 10 root 3. So in component form, the vector A will be expressed as I want to express this in component form now. It will be expressed as 10 I cap plus 10 root 3 theta. So this is the vector now expressed in component form. Whereas this here was the vector given in geometrical form. This was the geometrical representation, where we represent the vector by an arrow, where the length of the arrow designates the magnitude, and the direction of the arrow gives the direction in which the vector is acting. Okay. Yes, Yuvraj, that is correct. So next we will see that if we know the components of the vector and we want to find out its magnitude, then we can use Pythagoras theorem. That is in fact correct. Is designated by the symbol theta. So now that angle only is called theta. Yeah, Rishabh, I will scroll down. Don't worry. I'm just giving time for everybody to note down. So this is the representation in component form, where if I know the vector in geometrical form, to convert to component form, I have to use this form. That the x component is a cos theta and the y component is a sin theta, where theta specifically is the angle with respect to the x-axis. So this is an example of that. So this is expressed in component form, Dhyanendra. There's nothing to solve further. You've already expressed it in component form. Okay, let's do a numerical example next. Yeah, Harshul, I'll give you time, don't worry, to note down that part also. You missed it. Okay. So just try this out, people. Express these vectors, the four vectors shown A, B, C, D in component form. Yes, Aparna, your answers are correct. Very good. Because Nagesh, AX was 10. In the previous question, Naksh, EX was 10. That's why I used this. ये वैल्यू देखो कितना था 10 था क्यों 10 था because this EX was E cos theta was 20 cos 60, that was 20 into half, it was 10, and similarly EY, it was E sin theta was 10 root 3. So that's why the vector E in component notation is written like this. So EX is replaced with 10, EY is replaced with 10 root 3. That's how we get this. Okay, Naksh? That is the meaning of component notation. Now we write the vector. So now the same thing we have to do in all these vectors in this. Okay. So in this one you can see for the vector E, the magnitude is 25 and the angle with the x-axis is how much? 0, because it is parallel to the x-axis. So we know that EX will become 25 and EY will become 0. So the vector E will become 25I. Okay. Similarly, for the vector B, we can see that the magnitude is 20, but theta is equal to 50 degrees. So Bx will be B cos 50. That is 20 into root 3 by 2. So x component will be yes, Adinath, that is correct. So B's x component will be 10 root 3. And similarly, B's y component will be 10. So the vector B will be expressed as 10 root 3 I cap plus 10 j. So these are just the first two. Now similarly, those who haven't done this still, work out the third and fourth, C and D. Vyom, I'll check your answer. Just give me a second. No, Vyom, I've given the answer for the first one. It is not what you have said. The first one, EX is 25 and EY is 0. Yeah, Dhaneshwar, your answer for C is correct. Adina, check your answer for D. Yeah, for B it is correct. B, your answer is correct for the C part. Yes, Adinath, now it is correct. D is now correct for. Yes, Dhaneshwar, the magnitude of D itself is 10 root 2 units. It's 10 into root 2. So like this, you will see now in this for C, the magnitude of the vector is 20 again, but the angle with the x-axis is 60 degrees. So Cx will become 20 cos 60, which will be 10 root 2. And Cy will become 20 sin 60. Sorry, this will be 10. And this one will be 10. the vector C will become 10 I cap plus 10 root 3 j cap. Same vector we had seen earlier is the same one. And now similarly for the vector D, you will see that the magnitude of D is 10 root 2 and the angle is 45 degrees. So yes, it's correct. So x component of D is 10 root 2 cos 45. So that is 10 root 2 into 1 by root. That is 10. And y component is 10 root 2 sine 45. That will be the same actually. So that will also be 10. So the vector D now expressed in component form will become 10 I cap plus 10. So these are the four vectors expressed in component form. So just take a minute to go through this carefully and every one of you and ask me if there's any doubt with any of the parts. So D के लिए क्या हो रहा है बेटा देखो, if you draw the vector D separately, I just explained for D. For the vector D, I've just randomly given you D at a different place. Next, just hold on, I'll explain. Your question also I'll explain. I've just randomly given D somewhere over here. But I've given that D ka magnitude is 10 root. And I've also shown that if you draw a line parallel to the x-axis from its origin, this angle is 45 degrees. Okay. So that means that what is angle? So D makes theta equal to 45 degrees with respect to x-axis. Okay. And magnitude of D is 10. This is what it means. So basically, I can pick up this vector and place it here also. Nothing changes. It's the same vector. If I place the vector D at the origin, it will look like this. If this angle will be 45 degrees, because here this angle is 45. That is what it is. So that's why D's x component will be 10 root 2 into cos 45. So it is 10 root 2 into 1 by root. So that is 10. And similarly, these y component, d sine theta when you substitute, do all the same steps and we get that as well. So that's why the vector D is becoming 10 I cap plus 10 j cap. Alright, now next to answer your question, you can first of all see that there is no way that C and D should be the same. B and C should be the same because are their directions same? Only their magnitudes are same. And actually AY is 0 because you can see the component of A along the y-axis is 0. E is lying along the x-axis. E is lying along the x-axis. उसका y component है ही नहीं. So this is the reason why A is y component is 0 because it is parallel to the x-axis. This is the reason why its y component is 0. No problem. Okay. So hope this is clear, people. So this is why you can see one more thing also. Through this, you will understand the logic for another statement that I am making here. If you have a vector which is parallel to the x-axis, like the vector E that we have taken over there. For this vector E, theta is equal to 0 for the vector E because it is parallel to the x-axis. So that means whatever the magnitude is should be the x component. So what does that show you? That E cos 0 is P, which means cos 0 has the value of unity. Whereas EY should be 0. That means E sin 0 should be 0, which means the value of sin 0 is 0. So we have two more. Sin 0 is 0, whereas cos 0 is 1. It's just sin 30 is half and cos 30 is root 3 by 2. Like that, you have this additional set of values that sin 0 is 0 and cos 0 is 1. And the logic of this statement you can understand from here. Is this clear, people? Just make a note of this. Values of cos 0 and sin 0. Just make a quick note of this. Janeshwar, what you are asking, I am not understanding. Root 2 by 2 to 0 equal to 1 कहाँ लिखा है? ये लिखा है मैंने. E sin 0 is 0. That means sin 0 must be 0. See this equation now. Magnitude of A into cos 0 is equal to A only. What does that mean? That cos 0 must be 1. No? This is a standard value. If actual होता है that sin 30 is half and cos 30 is root 3 by 2. Purva, is this clear now? Cos 0 1 कैसे हुआ? Purva, is it clear? Okay. Okay, now understood. This is just a set of values. जैसे जैसे sin 30 का value half होता है और cos 30 का value root 3 by 2 होता है. Just like that, sin 0's value is 0 and cos 0's value is 1. Okay. Now, similarly, we'll see another thing. how we can get the value of cos 90 degrees and sin 90 degrees. Okay. So suppose A is a vector parallel to y-axis. It's a vector like this. So now how the vector E will be drawn? It will be drawn like this, parallel to the y-axis. So ऐसा होगा. So this angle will become 90 degrees. Okay. So suppose magnitude of vector E is capital E and theta is equal to 90 degrees with respect to x-axis. That is the meaning of this. So now the vector E will become what? It will become iit-jee because it is parallel to y-axis. So therefore, what will happen? X component of E will be 0. So that means E cos 90 degrees will be 0. So what does this tell me now? That this tells me cos 90 is how much? 0. And EY is equal to capital A only, the magnitude. That means E sin 90 degrees Students, there is some internet connectivity issue at my end. So just give me 5 minutes. I'm trying to sort it out. Okay. My internet connection is not working. I'm logged on through data network. I'm just trying to get myself online again. Then I can share the whiteboard. Just give me 5 minutes. I will try to sort it out. Okay. Okay, so people hopefully connectivity issues that are sorted now. So let's get on with lecture. So coming back to this example, let's pay attention on the whiteboard. So if we have a vector like A which is parallel to the y-axis, okay, then it should be expressed as A-J cap because its x component should be 0 and its y component should be the magnitude of the vector itself. So know the x component is expressed as A cos theta, and theta here is nothing but 90 degrees because it's parallel to the y-axis. So it should be perpendicular to the x-axis. So its angle with the x-axis should be 90 degrees. So that means A cos 90 is equal to 0, which means that cos 90 ka value kitna is 0. And similarly, y component, which is A sin theta, so that is A sin 90 is equal to A. That means sin 90 ka value kitna hai? 1. So this shows us the values of sin 90 and cos 90. This shows us that cos 90 has a value of 0 and sin 90 has a value of 1. So another set of values is now added for your list of sin theta and cos theta. Okay. So this is how we logically understand the value of sin 90 and cos 90. Yes, exactly. Parallel to the x-axis to A I cap हो जाएगा and parallel to the y-axis to A J cap हो जाएगा. Okay. So hope this is clear to all of you. Now next thing, moving on. If a vector is given in component form, then how to calculate its magnitude? So let's understand this. Now given any vector in component form, the magnitude of the vector will become how much? It will become root of ax square plus ay square. And this will come by Pythagoras theorem. This is from Pythagoras theorem. Because you can see that in this diagram, you have dropped a perpendicular here. And this value is nothing but ax. This value here is ax. And this value here is ay. So in this right angle triangle, this value is ay. This 90 degrees, and this value is kx. So the magnitude will be root of ax square plus ay square. So just note down this formula, people. Yeah, people. So hope this formula is clear. Now let's look at some examples of application of this. So calculate the magnitudes of each of the following vectors. So some acceleration is given to us, let's say, as 12 I cap plus 16 j cap in meters per second square. Some kind of an acceleration. So find the magnitude of this acceleration. Then secondly, let's say some force is given to us. F equal to, let's say, 7 I cap plus 24 j cap in dynes. So we have to again find the magnitude of this force. So just work out the answers and tell me each of these. And third, some let us say displacement is given to us. S as, let's say, 5 I cap plus 12 j cap in meters. So you have to find the magnitude of displacement. So just use the formula we've discussed just now and apply each of these and find out each of these. Give me the answers quickly, people. Yes, correct, Aparna. Very good. Yuvraj, correct. Dhaneshwar, correct. Aditya, correct. Aditya just expressed in correct unit. Unit of each of the quantities is given better. Second one is force in dyne. Dyne, as you know, is the CGS unit of force. Newtons is the SI unit. Dyne is the CGS unit. Correct, Ashok. Adinath, correct. Yes, Yuvraj and Dhaneshwar, correct. Only the unit will be dyne and not Newton. Okay, dyne is the CGS unit of force. So I'll just explain to you. Dyne is what we call the CGS unit of force. Okay. Force is mass into acceleration. So in SI unit is Newton, where we know that 1 Newton becomes 1 kilogram meter per second square. Okay. So like that in CGS system. So this is just about units. This is not related to the vectors concept over here, but just to understand the unit of that relation. So in CGS unit, dyne, 1 dyne is equal to 1 gram centimeter per second square. So therefore you can also see that 1 dyne is 10 raised power minus 3 kilogram, 10 raised power minus 2 meters per second square. So it is 10 raised power minus 5 kilogram meter per second square. So 1 dyne, which is a CGS unit, is actually 10 raised power minus 5 newtons. This is the relationship between Newton and dyne. So anyway, coming back to these vectors. So the first one, the acceleration was given to you as 12 y cap plus 16 j cap meters per second square. So the acceleration's x component was 12 and y component was 16 in meters per second square. So the magnitude of the acceleration, which is what I've asked you to find out, the square root of x component square plus y component square. So that is square root of 12 square plus 16 square, which you can take 4 common outside. So it's 3 square plus 4 square. So that is 4 into 9 plus 16. So 4 into root 25. So that is 20. So 20 meters per second square becomes the acceleration's magnitude. Okay, this is the complete working for it. You can, of course, skip some of the steps and do this directly, because you might just understand directly that 12, 16, 20 a Pythagorean triplet. So if you just understand this, you will come to this answer directly. Yes, it's correct, Dhaneshwar. Your answer is correct. Similarly, the second one, the force I had given you was 7 I cap plus 24 j cap in dynes. So that's what I think it was. Yeah. So again, you can see that the x component of force is 7 dyne and the y component of force is 24 dyne. So the magnitude of the force it becomes square root of x component square plus y component square. Okay. So this will become 49 plus 576. Okay. So that is square root of 625. So that is 25. So magnitude of force is becoming 25 times. Yes, that is where every day the recording is sent to you. So you will get today's lectures recording also. And the third part, the displacement was given to you as 5 I cap plus 12 j cap in meters. So displacement's x component is 5, y component is 12. So the magnitude of displacement becomes 25 plus 144. So that's square root of 169. So that is 13. So anyway, these are examples of how we calculate the magnitude of a vector given the components. So for this question, this is the working for the first two parts. Yeah, Rishabh, just a second. I'll send you definition of time. Okay. All right. Next, let us move on to the part where we understand how to do addition of vectors. Using components. So this is very simple really. Given vector E in component form as Ex I cap plus Ey j cap and B Bx I cap plus By j cap. Okay. Assuming the quantities E and V are expressed in same units. So for example, if A is displacement in meters, then V should also be displacement in meters. If A is a force in Newton, then V should also be a force in Newtons. Then we can find A plus B will become Ax I cap plus Ay j cap plus Bx I cap plus By j cap. So further in this we will use common algebra kind of concept that we can take I cap common, do this, and similarly we can take j cap common and do this. Okay. So this becomes our answer. So for example, suppose we have a situation where S1 is a displacement of 20 meters along I cap, and S2 is a displacement of, let us say, 20 meters I cap plus 40 meters J cap. We ask find the net displacement equal to S1 plus S2 and its magnitude. Okay. Yeah, I'll give you time to note. Don't worry. I should. Okay. So here I will do S net as S1 plus S2. So next step में क्या करूँगा, जो S1 and S2 दिया हुआ है component form में, I will just copy that over here. So I will just replace S1 with whatever S1 is given in component form above. So S1 will be substituted as 20 I cap. Okay. And S2 will be substituted as 20 I cap plus 40 J cap. Where both are in meters. Okay. So next I will take I cap common. So it will become 20 plus 20 I cap. And I'll take J cap common. It will be 0 plus 40 J cap. So the net displacement will become 40 I cap plus 40 J cap. This is my net displacement. Because the net displacement is nothing but the sum of S1 and S2. So that is becoming this. Okay. And the magnitude of the net displacement will become square root of its x component square plus y component square. So that is 40 root 2 meters, or approximately 40 into 1.41 meters. That is approximately 56.4 meters. So that becomes the answer. Okay. So this is the practical use of addition of vectors, and this is how we do the addition of vectors. So just make a note from here. Just open these two brackets, okay, and then take I cap common and J cap common. Okay, so what we are doing is this bracket and this bracket, we are just opening them. So we have Ax I cap plus Ay j cap plus Bx I cap plus By j cap. So that is, now you take I cap common. So we have Ax plus Bx, and take j cap common. So we have Ay plus By. Yeah, so 3200, that's the same thing as 40 root 2. No, beta. Square root of 40 square plus 40 square, if you expand it that way, that's square root of 1600 plus 1600. So that is square root of 3200. So that is square root of 16 into 2 into 100. So you can take 4 outside, 10 outside, and you're left with root 2. So that is 40. Yeah, you have to write in simplified form. Okay, so understood this. Okay, so the final step to find the magnitude of this. That's it. Okay, so let us now do a kinematics type of question based on this. So let's do a question based on motion in 2 dimensions. So a particle is moving on a 2 dimensional horizontal surface, which we are taking as the xy plane, such that it first makes a displacement of s1 equal to 20 meters along the direction at 30 degrees to the x-axis, followed by a displacement of 5 meters along the y-axis. That displacement is s2. So first of all, express s1 and s2 in component form, then show S1 and S2 geometrically as vector arrows in a diagram. Then third, find the net displacement as the vector sum of S1 plus S2. Fourth, find the magnitude of net displacement and also justify it from the diagram or geometrically. Okay. So just give this a bit of time and understand this question properly. So you'll understand more about how to use vectors in motion in 2 dimensions, which is the purpose of learning vectors right now. Try this out, people. Okay, so yeah, students, I'm going through your answers. Yeah, Aparna, correct. Yeah, Veer, correct. Right. So first of all, if we express in component form, we'll see that for the displacement S1, it is given to you that the magnitude of S1 is 20 meters, and this is at theta equal to 30 degrees with respect to x-axis. So the displacement's x component, S1x, let's say, become 20 cos 30. We've seen earlier today is 10 root 3 meters, and S1's y component become 20 sine 30, become 10. We've seen all this earlier today also. So the calculation should not be difficult for you at all. Okay. So in component form, the displacement vector S1 will be expressed as 10 root 3 I cap plus 10 j cap in meters. And the displacement S2 is very direct. S2 is 5 meters along the y-axis. That means its x component is 0 and its y component is equal to 5. So S2 vector will become just 5 j cap in meters. So this is the answer to the first part, the displacements in component form. So in case you haven't worked this out before, just note this down. Now, next thing you have to express this in the diagram or show it geometrically. Correct. Be your answers correct. Devanshu, correct. So now, if you represent this in a diagram, it will show up something like this. In the xy plane, your first displacement, say S1, like this. It's of magnitude 20 but at an angle of 30 degrees. And your second displacement S2 would be along the y-axis and of magnitude 5 units. That would be like this. You can draw it anywhere else also, it doesn't matter. The individual displacements you can draw like this and like this also, doesn't matter. As long as the values are correct. S1 is at 30 degrees to the x-axis and 20 meters. And S2 is along the y-axis and 5 meters. S2 was along the y-axis. S2 is given to us along the y-axis. And this is at 30 degrees to the x-axis, S1, and S2 is along the y-axis. All right, now the next thing we wanted to find out the sum of the vectors. So this is 10 root 3 I cap plus 10 j cap plus 5 j cap. So as you can see, this will become 10 root 3 I cap plus 10 plus 5 j cap plus 15 j cap. This is the net displacement in component form, and therefore its magnitude, the next thing, just becomes square root of 10 root 3 whole square plus 15 square. So here you can take 5 common. So this will become 2 root 3 whole square plus 3 square. So this will become 12 plus 9. So 5 root 21 is your answer. Magnitude of the net displacement. Now we'll justify this geometrically also, but just make a note of this first. This is the second part. Geometrical diagram for it. You find this in the first chapter. Okay, now let's understand the last part. Let's justify this magnitude of displacement that we got from the geometrical diagram. In the geometrical diagram, you can see that suppose our particle started from the origin and then it completed first a displacement of S1, which we had shown by that vector. It was like this. So it would have reached somewhere like this over here, where if you drop this perpendicular, this is 10 root 3, and if you drop this perpendicular, it is 10 from here to here, because this was your S1 vector. It's 10 root 3 I cap plus 10 j cap. Then it made a displacement of S2, which is along the y-axis, and was of magnitude 5 meters. So it would have reached some point like this. So S2 was 5 j cap. So if you drop this perpendicular here, you can see this is 5, all in meters. So now we want to talk about the net displacement. So you can see net displacement kya hoga. The starting point is the origin. This is the point from which the body is starting. And this is the final position after completing the two displacements. This is the final position after completing a displacement of S1 plus S2. Okay. So what is the net displacement in terms of the diagram? Displacement is defined as the vector from the initial point to the final point. So this is my net displacement. So this is the net displacement, which is the sum of S1 plus S2. Now ये net displacement के लिए देखो क्या हो रहा है, ये side कितना है? This side of the triangle, this one, this whole thing is how much? It is 5 plus 10, 15. And this side is how much? It is 10 root 3. So you can see it is 10 root 3 I cap plus 15 j cap. And therefore by Pythagoras theorem, the magnitude of the net displacement is the length of this hypotenuse. So ये वाले triangle में hypotenuse कितना है? It is square root of base square plus perpendicular square. So that will come out to be your 5 root. So that justifies the answer that we got here. So this is the geometrical method by which we have understood the magnitude of the net displacement. It's coming out to be this. So hope this is clear, people. Yes, this is a right angle triangle. ये जो triangle निकाला ना, ये right angle नहीं. This one. Look at this triangle. This is your S net. This is your x-axis. ये right angle triangle है ना? ये 15 है और ये 10 root 3 है. ये right angle triangle है ना बेटा? Understood भी? Okay. Sorry, Yuvraj, you understood this, I hope? That this is a right angle triangle. Okay, good. So let's look at another problem to wind up today's lecture. Okay. A particle starts from the origin O of an xy plane with initial velocity u equal to, let us say, (1.5 meters per second). Sorry, 1.5 meters per second I cap, and has a uniform acceleration So find its velocity v at the instant t equal to 2 seconds. Velocity v and magnitude of the velocity. And secondly, the displacement and magnitude of displacement from 0 to 2 seconds. Okay. So you can see that the initial velocity is along the x-axis, whereas the acceleration is along the y-axis. So that's why it's having a two-dimensional motion. वनिश का ये मैंने ऐसे किया 10√3 होल स्क्वायर था प्लस 15 स्क्वायर था ना square root in the previous question, that is. Okay, so I just wrote this as 5 into 2√3 whole square plus 5 into 3 whole square. So then I took the 5 outside. Okay. So this became 2√3 whole square plus 3 square. So that became 4 into 3 plus 9. So that became 20. So this is how the calculation was made. So Vanchika, hope this is clear, the calculation. Okay, now come to this question. Okay, but no problem. Okay, Shashwat. We are going to discuss the solution. Okay. So इसमें देखो क्या हो रहा है. Along your x-axis, the initial component of velocity is 3 meters per second, but the acceleration's component is 0. Okay. So it is what kind of motion? It is motion with uniform velocity along the x-axis. Okay. So therefore, at some time t, okay, the velocity will be how much? The velocity will be equal to ux only, it will not be changing. So the velocity's x component will be 3 meters per second. And the displacement, okay, along the x-axis, that will be how much? It will be vx into time. So the displacement as a function of time will become 3. This all is happening along the x-axis. This is what is happening along the x-axis. Okay. Now similarly, what's happening along the y-axis? Let's understand that thing next. So along the y-axis, your initial y component of velocity is 0, because your initial velocity, you go back, was just given as this. So this basically means what? X component is 3, and y component is 0. This means this. Whereas about the acceleration, what is given? It is only along the y-axis. Okay. So acceleration's x component is 0, whereas y component is how much? 2 meters per second. Okay. So EY is 2 meters per second square. So at some time t, the velocity along the y-axis will become EY into t. So the velocity will be given by 2t. And displacement along the y-axis will be given by half EY into t square. So the y component of displacement, उसका formula क्या हो जाएगा? T square. So now you put together these two things. Okay. So therefore, at t equal to 2 seconds, velocity's y component is 2 into 2, 4 meters per second. But so velocity vector is what? It is 3i cap plus 4j cap. So magnitude of velocity is root of 3 square plus 4 square. So that is 5 meters per second. So this is the first thing. But I think you've taken the values something wrong. Oh, sorry, I have taken the value. My mistake. So this is not 3. This is 3 by 2. Sorry, just make a correction here, people. So this is 1.5. So you just have to make correction here. So this value this value will change. This value, this value. Right. So ये कितना हो जाएगा? ये 1.5 होगा. And this will be 1.5 t. So this will be 1.5, whereas this will be 4. So this will be in meters per second. So the square root of 1.5 square plus 4 square. So that is square root of 18.25 meters per second. Whereas the displacement will become 5 meters. Yeah, I'm just finishing up. Okay. Tanisha, you can log out in a couple of minutes, just don't worry. Okay. And second thing, at t equal to 2 seconds, the x coordinate will become 3 meters. Okay. This is the x component of displacement. And the y coordinate will become half into 2 square. Okay, so that is 4 meters. This will be the y component of displacement. Okay. So the displacement vector will be given by 3 I cap plus 4 j cap in meters. Okay. So therefore magnitude of displacement will become, that is 5 meters. Okay. So this is the magnitude of velocity and this is the velocity vector itself. Okay. And this is the displacement vector and this is the displacement vector's magnitude. So that completes this question, people. And with this, you understood how we apply vectors to solve a motion in 2-dimensional plane, or what is called motion in a plane, or 2-dimensional kinematics, or whatever, these kind of things. Okay. So that's it for today's lecture, people. I will send you a list of some questions to do from the module. So you can refer to that and try out those questions as a homework assignment kind of thing. And next lecture, we will start with a discussion of that, and then we'll also eventually get into forces.